Hello, my name is Joe Minato, and today we're going to learn about the annular eclipse. Are you ready? Well, I'm ready. Understanding the annular eclipse of October 14th, 2023. Let's start off with a few pictures of eclipses. I'm not going to talk about these right now, but we'll come back and talk about them later. That's a pretty one. All right, here are 4 things I would like you to learn. What is an eclipse? What is a lunar eclipse compared and contrasted with a solar eclipse? And for solar eclipses, what is a partial solar eclipse compared and contrasted with a total solar eclipse? And then finally, what is an annular solar eclipse? All right, so an eclipse is when an astronomical body is in the shadow of another astronomical body. And that's anywhere in our solar system, in the Milky Way galaxy, or anywhere else in the universe. However, when we talk about eclipses here on Earth, we Earthlings usually mean the 2 main kind of eclipses involving the sun, the Earth, and the moon, lunar and solar eclipses. Lunar eclipses are when the shadow of the Earth covers the moon. Solar eclipses are when the shadow of the moon covers a small portion of the Earth. The moon blocks our view of the sun. So you'll notice that the adjective identifies the astronomical body that's being eclipsed. Remember adjectives, descriptive words? Lunar, the adjective, eclipse, lunar eclipse. Luna, or the moon, is eclipsed. Solar eclipse. Sol, the sun, is eclipsed. All right, so lunar eclipse we've established is when the moon is eclipsed, and they can last for hours. Here's a picture. If we look here, here is the sun off to the right. Here is the moon. No, that's wrong. Here is the Earth, sorry. And over here is the moon. Actually, the moon there's 3 pictures of. Notice that this diagram is not to scale, and that's common with astronomical diagrams because space is so huge that you can't really draw things to scale. So the sun shines on the Earth, and that casts a shadow. The shadow actually has 2 parts, the darkest part, the umbra, and the less dark part, the gray part, the penumbra. We're not going to focus too much on that today. What we are going to focus on here is that the moon is in orbit around the Earth. And of course, the Earth is also in orbit around the sun. And about once a month, the moon lines up on the far side of the Earth from the sun. And sometimes the shadow of the Earth covers the moon. The moon goes into the shadow of the Earth. Notice the shadow of the Earth is bigger than the moon, and the moon is fully immersed in the Earth's shadow. Half the world, well, if it were clear, half the world could see a lunar eclipse. Actually, since they take a few hours, it's a little more than half the world. Of course, it's not clear everywhere, but in more or less, about half the people can see a lunar eclipse. Solar eclipses are when the sun is eclipsed, and they last for just a few minutes. Here's another picture. This time the light from the sun is off to the left, and this time it hits the moon. Now the moon, as you know, is smaller than the Earth, so its shadow is smaller. And so over here, the Earth is too big to fit entirely in the moon's shadow. And in fact, there's just a little dot on the Earth where the moon's shadow falls. So only a tiny fraction of the people on the Earth can actually see a solar eclipse. Most of the people on the Earth don't see the solar eclipse at all. Now, here's an interesting picture. Here are 50 years of solar eclipses, and it's got the globe of the Earth shown in 3 different views so we can see everything. And you can see here these little patches. Here's one in 2060 that goes through Africa and up into Eastern Europe. And here is one, 2017, that went through Oregon and all the way across the United States. Some of you may remember that. And then there's one in 2024, just a few months from now, that goes through the United States, but at a different path, coming in here from Mexico and going up through like Newfoundland or so. You can see that when there's a solar eclipse, just a tiny little strip of the Earth experiences the eclipse. And oftentimes, since the Earth is mostly water, that's off at sea. A given spot on the Earth can only see a solar eclipse once every 360 years. It's a long time. Okay, partial versus total eclipse. When the moon blocks all of the disk of the sun, you witness a total solar eclipse. But much more often, the moon blocks some, but not all of the disk of the sun, and you witness a partial eclipse. So let's look at this picture here, the top one. The sun is shining on the moon. And as we mentioned before, a shadow has a dark part, the umbra, and a less dark part, the penumbra, the gray part. Only a small portion of the Earth is in the umbra. If you were right here under my red dot in this particular example, there in West Africa, only people in that small dot would see the sun totally blocked by the moon. The people in this larger gray circle would see a partial eclipse. And the reason for that is if you're in the gray circle, the moon is blocking some of the sun, but not all of it. If you're very close to the dark circle, it's blocking almost all of it, but not all of it. And if you're way out here on the edge, it's only blocking a small amount. But still, even the large gray circle is a small fraction of the Earth. Most of the Earth doesn't see an eclipse at all. Again, contrasting on the bottom picture with a lunar eclipse, the moon is fully immersed in the Earth's shadow for several hours sometimes. And that means anyone who is experiencing nighttime at the time of the eclipse and who has clear weather can see the lunar eclipse. All right, now we need to talk about the annular eclipse. Well, first of all, that word sounds a lot like annual, and you probably know what annual means. It means every year. Your birthday is an annual experience. Happy birthday. So are most holidays. First day of school, annual experience. This word is annular. It sounds a lot, but it doesn't mean anything the same. An annulus is a ring, like a wedding ring you might wear. That's a mathematical term is annulus. An annular eclipse is also known as a ring of fire eclipse. So we got to learn a little bit about why there's sometimes annular eclipses and how they're different than total eclipses and how they're different than partial eclipses. And now they're the same as those things too. So it turns out that the moon's orbit around the Earth is not a perfect circle. We usually draw it as a perfect circle, but it's not. It's actually a little bit of a squashed circle, more like an oval. The official mathematical name is ellipse, which sounds a lot like eclipse, but it's not. But we're not going to talk too much about ellipses today, other than to note they exist and they're slightly squashed circles. So sometimes when there's a solar eclipse, the moon is too far away from the Earth to block the entire disk of the sun. And that's a special type of solar eclipse called an annular eclipse. Now here is another picture. It's a great picture, but it's exaggerated. Okay, this picture is not to scale as we discussed before. There's a few things wrong with it. First of all, this oval or ellipse that shows the moon's orbit around the Earth, it's not that squashed. Okay, in fact, it's pretty close to a circle, but we drew it exaggerated to make a point here. Secondly, there's the Earth, and we know that the moon is a lot smaller than the Earth. It's about a quarter the diameter, and we've drawn the moon much bigger. So you might think, what, was the artist just messing up? No, the artist made these exaggerations on purpose to show a point. Point number one is that the moon's orbit around the Earth is not a circle. Sometimes the moon is way over here at apogee. That means it's furthest place from the Earth. And then it takes a month or so and it goes around its orbit. And sometimes it's over here at perigee. That's when it's closest to the Earth. Now, you know that when things are closer, they appear larger. And when things are further away, they appear smaller. So when we have a moon at perigee, it appears larger. You may have heard about that. It's called a supermoon. But you probably haven't heard about the opposite of a supermoon, a mini moon. I don't know what you call it, an anti-supermoon. Make up your own name, but it's when the moon is at apogee, furthest from the Earth, and it appears smaller. Now, of course, the moon is the same size. It's further away, and it appears smaller. So remember that we have eclipses when the sun, Earth, and moon line up. And sometimes when we have a solar eclipse. They line up when the Earth is at perigee. The moon appears bigger, and it blocks the whole disk of the sun, and we get a total solar eclipse. Other times, they line up when the moon is at apogee, and the moon appears smaller, and it's not big enough to block the entire disk of the sun, and we get an annular eclipse. Of course, most often it's somewhere between apogee and perigee. If it's close to apogee, we get an annular eclipse, and if it's close to perigee, we get a total solar eclipse. I know, it's confusing. Hang in there. That is what an annular eclipse looks like. So that is the disk of the sun in the background, and the dark part is the moon. And as you can see, the moon and the Earth and the sun are almost perfectly lined up here. It should be a total solar eclipse. But it isn't, because the moon is near apogee, further in its orbit from Earth than usual, appearing smaller, and it's not big enough to block the entire disk of the sun. It's a pretty special occurrence. Here are all three kinds of solar eclipses. The total solar eclipse, that's when the moon entirely blocks the disk of the sun. That's the kind we had in 2017, and the kind that's going to happen in another part of the US and another part of the world next April in 2024. Because the bright disk of the sun is blocked, you can see this wonderful phenomenon called the corona, not related to coronavirus. They both come from the root word that means crown. Crown, this is the crown of the sun. We won't see that with the annular eclipse, because this middle one is the annular eclipse. The moon's not quite big enough to block the sun. So we're going to see a ring of fire around the sun. And this one on the right is a partial solar eclipse. That's when the alignment isn't quite perfect, and the moon gets in the way of the sun, but it doesn't pass directly in the middle. So even if it's big enough, it doesn't block all of the sun. That's a partial eclipse. Now, it's kind of interesting. One can make an argument that an annular eclipse is a partial eclipse because it's partial. Some of the disk of the sun is exposed. Some people could even argue that an annular eclipse has something in common with a total eclipse because the alignment is perfect. But you really shouldn't call it a total eclipse because the sun is not totally eclipsed. Annular eclipses have something in common with total solar eclipses and something with partial, but I prefer just to call them annular eclipses. They're their own special beast. And if it's clear, we'll get to see one. All right. Did you learn these four things? Could you say it out loud? What is an eclipse? All right, everybody. 1, 2, 3. What is an eclipse? Oh, well, that was quite a racket, but I think you got it. 2, what is a lunar eclipse? What is eclipsed in a lunar eclipse? Ready? 1, 2, 3. Good. Hopefully you said the moon or Luna. And what is eclipsed in a solar eclipse? 1, 2, 3. Well, I hope you said the sun or sol, or some other name you have for the sun. I usually say the sun or sol. 3, what is a partial solar eclipse compared and contrasted with the total solar eclipse? Okay, think about that one a little bit. How are those the same and how are they different? Ready, go. Okay. So their names are pretty descriptive. That adjective there, partial, means the sun is not entirely blocked. And a total solar eclipse means the sun is entirely blocked. And finally, the main point of the day, what is an annular eclipse? First of all, what's an annulus again? It doesn't mean every year. Okay. It means like a ring. And in this case, like a ring of fire, because it's a ring of the sun. And it's that unique eclipse when the alignment is perfect or nearly so. The moon goes right in front of the sun, but the moon is near apogee, its furthest part from the Earth, and it appears smaller, and it doesn't block the entire disk of the sun. All right, so it's not going to be just about listening to me. Don't worry, we're going to do an activity that I'm calling Make Pinhole Eclipse Viewers. All right, so the supplies are in your classroom, and your teacher will help you with these. And I'm going to just show you a few of the things we're going to do. Here is a arranger for, I think it's the National Park Service. I think her name was Clarice. And she demonstrated this. And she just took an index card, an everyday index card, and she poked a hole in it. And then she turned her back to the sun and she held it up like that. And of course, it cast a shadow on the ground. So did her body. And so she would first see her head and shoulders, and then she'd see the shadow of the card. And then, and see her other hand, she took another card and she cast the first shadow of the first card on the second card. And this is what you see. You see a little round dot. That is the image of the sun. You just made one of the very first and simplest astronomical instruments, a pinhole viewer, the simplest possible pinhole viewer. And this is one way to see an eclipse of the sun. Now, Clarice was out here on a sunny day that was not an eclipse. So the image is a circle. The sun is a sphere, and so it projects as a circle. During an eclipse, what would this shape look like? I'll bet you know. And it would change during the partial eclipse time. Very cool. So that's a super easy activity. You don't have to use index cards, any piece of paper or cardboard, and just a little push pin or something to make a little hole in it. Well, that's pretty easy. So here's a more advanced eclipse viewer. So in this case, what you do is you take your card and you cut a hole, and then you paste tin foil, aluminum foil really, that you'd use in the kitchen across it, and you poke a little hole. It's kind of the same idea, except for it turns out you can make a smaller, better hole in tinfoil than you can in paper. And then you can often get a better shape. And this picture I took at the eclipse of 2017 in a little town in Western Oregon called Monmouth, where Western Oregon University is. I'm sorry, I don't remember this woman's name, but she was one of the many participants at our eclipse events. And you can see what she got just on a back of a little piece of paper plate. She got a partial eclipse of the sun, and it tends to work better with the aluminum foil, but you don't always have aluminum foil handy. Well, you can also make a much more advanced pinhole viewer, and I have a few of these around the classroom. And if you come to our activities tomorrow, I'll tell you more about that in a bit, you can make your own. You need some basic supplies, just some sort of cereal box, some aluminum foil, white paper, scissors, tape, push pin, and pencil. I'm not going to explain to do it right now, but we'll help you do that tomorrow at the Chiloquin Community Center. And you make one of these. It's the same idea, the same basic scientific principles, but the image is inside a box, so it's much darker and thus appears much brighter. All right. And here's a very fun thing to do. One time when I was at an eclipse leading activities, a little 5-year-old girl taught me this trick. It's true. I had never thought of this before. This was a long time ago. And she took her index card and she made little pinholes that spelled out in cursive. She was very proud she knew cursive. And she made her name Lindsay. And then she held it up to the sun and then had a screen. And if you look very closely, can you see that each of those little dots is the sun? And it's not just the sun, it's the sun during the partial phase of the total solar eclipse. And you can see that there's little bites out of all of them. That's very easy for you to do. We have plenty of cardstock in the classroom and plenty of push pins, and you could put your name or a special message to someone, or I love eclipses, or whatever you wish, or maybe just a piece of artwork in push pins. And then when the eclipse comes, you can hold it up, cast it onto a screen, and you will get a very artistic pinhole viewer of the eclipse. And you don't have to restrict it to eclipses. The sun's out a lot of the time. You can do this anytime that the sun is out. You just won't get the shape of the eclipse. Now, of course, the best activity of all is to observe a real live eclipse. And we're lucky because one's passing through our town of Chiloquin, and we don't have to go anywhere. Oftentimes, people have to travel great distances to see eclipses. So tomorrow at the Chiloquin Community Center, we're going to have a lot of activities. And on Saturday morning, if it's clear, which we hope it is, we're going to have an eclipse viewing. And there's a few things you need to know, okay, about viewing an eclipse. But I'm going to actually pause right here, and you can pause the video, because I want you to do the activity first, and then we're going to come back to this. All right. Did you pause? Did you do the activity? Did you have fun? I hope so. By the way, there's 2 versions of that activity that your teacher knew to do. If it was sunny, the best one is to go outside. But if it's not sunny, if it's cloudy, you can't do that. and I had an indoor version. So that's okay. We can't control the weather. And whichever one you did on another day, you can do the other one. Pinhole viewers are actually quite interesting. All right. So now I want to talk to you about viewing the actual eclipse. Well, you're old enough to know that you should never look at the sun. No, no, no. Never. Don't do it. Don't do it ever. Don't look at the sun. And especially never, never look at the sun with any kind of magnification, with a telescope, with binoculars, with a magnifying glass. Not even for an instant. Could cause permanent, irreparable, disastrous eye damage. Don't look at the sun. If you're going to look at an eclipse, there's several ways to do it that are safe. And one way is to use eclipse glasses, which I'm leaving with your teacher to hand out. And I'll have some at Spinks Park on Saturday morning. And this is special film that reduces the brightness of the sun by a huge factor. And you can look directly at the sun with these glasses on. Okay, only with the glasses on, not without the glasses. And you have to make sure that they're certified eclipse glasses, the ones I gave you are, and you have to make sure they're not damaged. And finally, you have to make sure you're wearing them correctly. That's not too hard. It just means they're totally covering your eyes, and you don't stare at the sun and then put the glasses on. Okay, you look away from the sun, put the glasses on, and then look at the sun. Then when you're done looking at the sun, you turn away from the sun, take the glasses off. So here is our annular eclipse on October 14th, and it's going through much of the United States, and we can see here through much of Oregon. Chiloquin is right here, almost at the middle of the eclipse, and it goes down here in kind of an angular path from the coast over past Grants Pass and down south of Klamath Falls and up here from Corvallis, just south of Bend, and off almost to the corner of Oregon right there. So anyone that's in here is going to see annularity. They're going to see the Ring of Fire eclipse. If you're outside of this area, but still in Oregon, you're going to see just a partial eclipse with no annularity. So we're pretty lucky being right here. Oh, but we needed to be clear. And we're going to have a bunch of activities, which I was just telling you about. First of all, tonight, if it's clear, Thursday, October 12th, 7 to 11, we're going to have a nighttime star party. There'll be astronomers with telescopes to look at the night sky. Of course, only if it's clear. And how do you know to go or not? Well, here's a QR code that maybe you have a smartphone, or I bet your parents do, or someone you know. And you can scan that around 6 or 7 o'clock, and I will update that. And if it's clear enough to have the star party, I'll say we're on. Let's go. Meet you at Spanx. And if it's not, we'll say sorry, but we'll try again another time. And then tomorrow, regardless, what did I just do? Hold on. There we go. Tomorrow, we're going to have a bunch of eclipse activities at the Chiloquin Community Center from 1 to 4 o'clock, free and open to everyone. I'm not going to tell you what they are, but they're hands-on and they're fun. Okay, kind of like the pinhole viewers, but there'll be those, but then all kinds of other fun activities too. And then at 2 o'clock, I'm going to give a version of this talk again, but you've already heard it. It'll be for other people who come, and you can you watch it again if you want, or you can help other people or do more of the activities. And then at 3 o'clock, a professor of astronomy from Central Washington University, Dr. Darcy Snowden, she's going to be in town with a bunch of her college students, and they're launching balloons, what you might call weather balloons, but they're really scientific balloons. And they're going up to like 100,000 feet. Wow. Like 30 kilometers, like 20 miles above the surface of the Earth. And they're doing experiments. And she's going to come, or maybe one of her students. We'll have to see whether it's her or one of her students, probably a combination. And they're going to give a short talk on why they're doing this and how it's interesting and how you can watch and take part. That should be really cool. And that's independent of weather, I think, unless it's really windy. They can't do the balloons if it's really windy, but they can if it's cloudy. And on eclipse day, even if it's cloudy, they're going to send up a balloon with a camera in it up above the clouds. So we'll get to watch that video of the eclipse. And then finally here is the eclipse viewing event, and that's Saturday, October 14th, 8 to 10:30 at Spinks Community Park. Once again, I've got a QR code. You can check that. So if it's cloudy, you can go check and see, are we going to run the eclipse or not? And I will update that probably around 7:30 in the morning. And you can check. And I'll be on hand on lots of other astronomers, which will help you with fun activities and certainly help you be safe viewing the eclipse. All right. So what kind of an eclipse is this? Does anybody want to guess? Yes, indeed. That's a lunar eclipse because we can see that's the moon. And you might think, well, how come we can see it if it's eclipsed? Oftentimes, lunar eclipses turn blood red. Sometimes they're called blood moons. That's a different lesson. I will say this. It's for basically the same reason that sunsets are red and sunrises are red. But we'll have to talk lunar eclipses another day. What kind of eclipse is that? It's a total solar eclipse. And this feature out here, it's the corona. Now, we won't see that Saturday no matter what. The next one will be April 8th, 2024, not in this part of the United States. What kind of eclipse is that? A total solar eclipse. No, it's not. It's a partial solar eclipse. I misspoke. A partial solar eclipse. And this is an annular eclipse that I hope we're going to see tomorrow. Viewing it appropriately with our eclipse glasses, or maybe our pinhole viewers. Hey, thank you so much. I hope you enjoyed this, and I hope to see you around. So long.